In this video I want to show you how to make an Android application that can communicate with your ESP8266 and Arduino. So what I have here is an Android app with two text boxes. One of them is for the IP address of your ESP8266. The other one is for the port number. So this screen that you see here, this phone application, it's a live screen from my phone. I have it connected through the USB and doing a screen capture. So if I press button pin 11, for example, then the button on pin 11, the LED on pin 11 will turn on, as you can see, and I also get a dialog message that tells me the state of the LED. So the string that you see in this dialog message that says pin 11 is on is coming from the Arduino. So that is a reply from the Arduino back to my phone. Let me go ahead and toggle the LED off. So I'm going to press the button. The LED is now off and I get a message that says pin 11 is off. Now the application actually works pretty fast. So there might be a delay as you're looking at it right now from when I press the button and how long it takes for the dialog to display, but that's because the screen capture software that I'm using is not in real time. It takes a couple of seconds to get the screen. But anyways, now that you know how the application works, let's go ahead and check out the Arduino and Android code. So let's start off with the Arduino code. The code is almost exactly the same as the one from my video about toggling the Arduino pins from a web page. So if you watch that video, you know most of this code already. So I'm not gonna go through the steps for this code, the part of the code that is the same, but the only things that you're gonna have to change in this code are your network's SSID and password. So mine, of course, is AAA so that's my SSID, and just go ahead and type your password here, and I will have this code posted in my website. If you're watching this on YouTube, you can find the link to it in the description of the video. So like in my previous code for the web server page, I check a connection by looking for the string plus IPD. So that's when I know that some device is attempting to connect to the ESP8266. So when that string is there, I know that my phone is trying to send some information. Then I look for the string pin equals. So that is my variable or my parameter that I'm looking for. And then I get the pin number. So that is how I get the pin number. Right now, as it is, the code only works with 2-digit pins, but I will modify it so that it works with every pin. But just make sure that you don't use the pins 0, 1, 2, or 3, since those are the pins connected to the ESP and also used for serial communication. So if you try to control those, then your Arduino is just gonna stop working, so don't use those pins. So this is where I build the reply that is sent back to my phone. So it says pin is, and then I choose if it's on or off based on the state of the pin. I made a couple of functions. I made a function called send HTTP response, send command, and also send data. So basically, when I get a connection from my phone, like I said, I get the pin number. So I get the pin number. Then my content is whatever I want to send back to my phone to be displayed in the dialog box. So in that case, its pin is either on or off. Then we go to this function that says send HTTP response. So this is where I build my HTTP header. So you always need an HTTP header if you want Android to read back the data. So if you omit the header, then you won't be able to get the response if you just send the content. And then of course after the header in a HTTP request, the content is followed by the header. So I simply concatenate these two strings. There's actually a bug in my code that I couldn't find what the problem was, but let's say that the pin was on, then the letter N will not show. If the pin was off, then the last F of the word off will not show for whatever reason. So what I did is I added an extra space, and everything's working fine. But it is a bug, so just keep that in mind if you run into a problem where the last character doesn't show or something like that. It might be related to that. But anyway, so after I create my response, that becomes the data that I want to send back to the phone. So I created this function called send CIP data, which is related to the CIP command. Of course, in all my previous videos, I've shown you how the C8+ CIP send command works. You know, you need the connection ID, which I retrieve. So that is a connection ID for each device that is connected to the ESP, and then you send the length of the data. So in this case, that would be the length of this string. And once I have my CIP command, then I simply send it, and then I send the data, which is the HTTP response. So my send data command simply writes the response to the ESP8266. I had to use the write function so that I can write more than 62 characters, since obviously my HTTP response will be more than 62 characters. So I can't simply use serial write. I have to use the version of the function where you put the data and the size of the data, or the size of this array. So this is the Arduino code. Like I said, it will be posted in my website. Now let's go ahead and check out the Android code. And if you're having trouble with understanding any of this code, like I said, watch my previous videos. I explain each and every line in detail. So the Android app was built in Android Studio. You can also use Eclipse, but I prefer Android Studio. I've actually used both. So the only 3 files that you have to worry about are the home activity file, which is the Java code, the manifest file, and also the layout file. So those are the only 3 files that you have to change from when you create the project. So I will post the code for these 3 files in my website as well. Let's check out the layout file first. So my layout file is located in this folder. That's where I build my user interface. So this is where I create my text boxes. So this is the IP address text box. This is just my port number text box, and of course my 3 buttons for each of the pins. So this is pin 11, pin 12, and pin 13. You can add more buttons if you like. So that's what my layout file does. Now the Android manifest file, the only line that I added to it from what was created by the program, is this line, which lets your phone use the internet, or lets your app use the internet. So this line requests permission from the phone to use the internet, to use an internet connection. So that is the only line that I added. My home activity file is the one that processes the clicks and the input of the text. So one thing that my app does is that it saves the IP address and port, so that when you close the app and open it again, it'll still be there and you don't have to type it again. But anyway, so inside my onCreate function is where I create my buttons and set the listeners for my buttons, and also create my text boxes and set the text for the text boxes. So if I've already typed an IP address before, then this is where I retrieve the IP address and put it in the text box. If it's the first time that you open the app, then nothing will be put in the text box. So let's check out what happens when you click on the button. So when you click on the button, I get the button ID, compare with the button that you click, and find out which of the buttons you clicked. And I create this variable called parameter value. So if you click button 11, then that value becomes 11, and that would be the pin number that I want to toggle. This is where I execute my HTTP request. So my parameter value is the pin number, this is the IP address, this is the port number, this is the parameter name. That word pin has to match the word pin in my Arduino code in this line. So this word pin in my Arduino code has to match this word in my Android code. So I created a function called send request where my HTTP response is executed. This is where I build the URI or the URL that is sent to the ESP8266. So this is the IP address, this is the port number, parameter name, which would be pin, the equal sign, and the parameter value, which would be the pin number that I want to toggle. These two lines is where I get the content that my Arduino sends back to the phone. So I read the line and then I save the response. So this variable right now is going to contain the words pin 11 is on or is off, or pin 12 is on or is off. So this variable is where the string that I'm building here is saved in. And then of course you have to close your connection. So that's where I close my connection from the phone to the Arduino. I have a class here that is an Asynctask. So an Asynctask is required because an HTTP request will block user interaction with the app, and it might freeze your app. So an Asynctask lets you run processes, like in this case the HTTP request, in the background so that the app will not freeze. And inside of this class is where I also create my dialog. So this is my dialog box, that's where I give it the title, and I create it. And of course, so this do in background, that is what I want to do in the background. And what I want to do is I want to send a request, and then I get the string from the request, and there's a function called onPostExecute. So this is where I once again change the message of my from my dialog to whatever the Arduino replied with. So if you remember from my app, initially it has a string that says we are sending the data, or the data was sent, and then that changes eventually to pin 11 is on or pin 11 is off. This is whatever I want to do before the function is executed. And but you don't have to call the functions individually. Like I said, all those three functions are called whenever you create a new instance of the Asynctask and call the function execute. So this function execute runs the three functions, which are on pre-execute, doing background, and on post execute in that order. So all of this code will be posted on my website. That's it for this video. Thank you for watching.